This next video is a complement to the buffer video where the curve this morning went from high to low when we added an acid down here to a base. We're adding a base here to an acid, so we just need to pick out which one is the right acid. Now, even if you've never done a titration curve, that's not an issue in this course. I just want to point out like 3 features. One is, of course, this region here that doesn't change in pH, and we talked about it briefly about a minute ago, and we called that what region? Buffer region. Why is it called that? Because the pH changes very little. This point where we are at 24, going straight down there, trying to get it on the 24. Yeah, we'll move the graph. That's one way to do it. I can't get it on the 24, but it's on the dot. The dot is where the slope changes from going that direction to that direction, or vertical. And that's called the inflection point, but you don't need to know that. We call it the equivalence point. And at the equivalence point, your titration is over. Wow, equivalence. Equivalence point. So when you began, you had 100% acid. When you're done, you have 100% conjugate base. We need to know when we have equal amounts of acid and base, which is the base on top, the acid on the bottom, and when you have equal amounts of A minus and HA, how does this expression simplify? When HA equals A minus, how does this statement, or this equation simplify? pH equals what? The log of 1, please. I don't want you getting out calculators because you don't do that on Monday, but you're supposed to know the log of 1. What power do you put on 10 to get the answer 1? What power do you put on any number to get the answer 1? 0. Okay. So the log of 1 is 0. So what's pH? The whole expression is pH equals pKa plus the log of A minus over HA. What is the pH when the amounts of A minus and HA are equal? That's the whole reason we need to go to the half equivalence point. Where is the half equivalence point? If it took 12 milliliters of base to get the full equivalence, where's the half? Oh, sorry, I lied. 24 milliliters of base. No wonder you had a confused look on your face. That was my mistake. It took 24. I got money bet that this morning's number was 12 for the full equivalence and 6 was half. I got money based on that, but that's where my mistake was, but that doesn't help you. It just makes for a confusing video. 24 was the full equivalence. After 24 milliliters of base, you had 100% A minus. You had 100% HA when you added no base. Where's your half equivalence? You can say your answer again this time. 12, thank you. So we got a 12. Yeah, I want to draw a straight line. Not bad. And I want to know what pH exists at the half equivalence now. Oh, wow, I did a good job. Well, pretty close. Computers help a lot. That's even better. So what's the pKa of this acid? Wow, don't move my graph after I did all that hard work. Okay. pKa roughly 3.6, 3.7. We don't know any pKa 3.7, but we do know RCO2H, pKa equals 5 if R, and this is perfect with our first video, has an inductive effect, pH goes a little below 5. So carboxylic acid, close, but not close enough. I need a carboxylic acid that also has a halogen nearby or something else electronegative nearby. One of your answers have that at all? Don't pick answer D. That's not a carboxylic acid. It has the halogen. But D, I would guess to be pKa roughly 16. How about AB? That fits my sentence perfectly, doesn't it? AB? Yeah. Let's just call it the answer and call it a day. Well, not a day. There you go. If this came to 5, I would have picked E. If this was up here at 5, this blue line, I'd pick E. I can make any of these the right answer, by the way, just by changing my y-axis. Guess how Dr. Whitaker designs this question? He's got this drawing done. He changes the y-axis and he's done. I can make any of those the right answer. Do you want me to do a good summary of what pKa is to expect for each answer? It's good review. 6 for the first one. This is pKa review. 11 for the next one. 17 for this one. A bit of a lie because it's ethanol. It should be 16. That's okay. This one I just see 17 down. So it could go down to 15.
So just with the
Inductive effect, right?
just with the fluorine or any.
Just with any fluorine, chlorine, bromine all have an inductive effect.
Okay.
And they diminish because fluorine's the best, right? I generally like the fluorine because you know, hey, there's an inductive effect. And then a 5, and then a 5 down. And then a 10, and then a 10 down. I don't know, 9 or 8, you know, within 2. So, hey man, wonder if one of those answers is going to be the answers on Monday. I think maybe. Or look at this morning's video. Maybe I'll go that way. Okay. And you've had enough about titration curves, I can tell.